All right, I thought I'd run through a real quick review of Chapter 2, which is on polynomials. So the first thing we did was name polynomials. So just a real quick review. You can name them by degrees or by the number of terms. Remember, this is degree 0. There is no variable. So degree 0, we call it constant. This one, the highest power is 1, so we called it linear. This one, the highest power is 2, we called it quadratic. This one's highest power is 2, it's a quadratic also. The bottom one, the highest power is a 3, so we call it a cubic. Anything past there, we didn't memorize names for them. Hey, number of terms. This first one, just counting terms. This only has one term. We call it a monomial. Mon, the prefix means 1. The second one has 2 terms. So the prefix for 2 is bi, so binomial. This one's also 2 terms, so it's also a binomial. This one's got 3 terms, so it's a trinomial. And this last one's got 3 terms, so it's a trinomial also. So if you look at this problem, like name these polynomials, well, by degree, the highest power is a 3, so I say it's a cubic. By the number of terms, it's got 2, so I call it a binomial. This one, the highest power is a 2, so it's a quadratic. And it's got 3 terms, so we call it a trinomial on that one. We added and subtracted. So the main thing here is just write them without the parentheses and then combine like terms. So I'm going to write this first one without the parentheses. Remember, if there's a plus, the signs don't change. So everything just stays the same. Just write them without the parentheses. Okay, combine like terms. We're going to start with the highest powers. I got a negative 3a to the 4th. I've got a 7a cubed. Let's see, I've got a 5a minus 7a. That'd be minus 2, right? You go 5 minus 7, and the a just stays the same when you combine those. And I've got a minus 5 minus 2, which is a minus 7. So I combine like terms. When you write it with the highest power, and then you go down in order of degree, so 4th, cube, first power, constant. When you do that, we say it's written in standard form. Okay, the second one, we've got subtraction. When you go to subtract, same thing, write them without the parentheses. But what you have to be careful of is that minus carries through. So it's minus x squared minus 6x cubed. So you got to make sure that minus carries through to both of them. Now combine like terms. I've got a minus 5x cubed and a minus 6x cubed. Minus 5 minus 6 is a minus 11. I've got 2x squared minus 1x squared. 2 minus 1 is 1. And I've got a positive 7, so it's a plus 7 on the end there. Okay, so when you're adding and subtracting polynomials, write them without the parentheses. Make sure pluses, they don't change. Minuses, you switch signs. And then you're just combining like terms once you've done that. Hey, multiplication. Most of us are really good at this, right? This is just the distributive property. 5e squared times 5e squared would be 25v to the 4th. 5e squared times a minus 3 minus 15v cubed. 5v squared times a minus 3 would be a minus 15v squared. This next example, I'm actually going to skip past this one and go down to this bottom one. When we multiply something that has more than one term, make sure you just take each term, like the x, for example, and distribute it all the way through. So that'd be 5x cubed minus 3x squared plus 2x. Okay, and then do the same thing here. 3 times 5x squared, 15x squared. Okay. 3 times minus 3x, and 3 times a positive 2. So you just got to make sure each of those terms, right, the x is distributed all the way through, and the 3 is distributed all the way through. Okay, combine like terms, I got 5x cubed. We can combine the minus 3x squared plus 15x squared minus 3 plus 15 is plus 12. I've got 2x minus 9x, 2 minus 9, minus 7. I've got that plus 6 on the end. I've combined all my like terms, and I'm done. Hey, up here on this one, right, same thing, 4m, that whole FOIL thing. You do the same thing. Just make sure you distribute the 4m all the way through and the minus 1 all the way through, and then combine them. The part that most of us have the hardest time is factoring. So I wanted to go through an example for each of the types. A greatest common factor is the first type. That's the first thing you always look for. That's why it's at the top of that. So here's an example. If I have 20x to the 4th plus 5x, we've got a common factor here, right? Between 20 and 5, it's 5. They also all have at least one x. So I can take out a 5x. Well, 20 divided by 5 is 4. X to the 4th divided by x is x to the 3rd. 5 divided by 5 is 1, and I took out the x. Okay, so I just factored that using the greatest common factor. On every single problem, it doesn't matter if it has 2 terms or 20 terms, it doesn't matter. You always check for a common factor first. All right, let's go back. Once you've taken out a common factor, right, that's the first thing you always do right at the top. Once you've done that, then you're deciding how to do it by how many terms it has. So if it has 2 terms, the only way you can factor it is what's called the difference of squares. So let me just remind you what that pattern is, and then we'll do a couple of problems. Difference of squares is when you have a squared minus b squared. You take the 2 things being squared, you take a and b, and you have to include them both in your 2 sets of parentheses. One has to be a minus, one has to be a plus. So that's the difference, we call this the difference of squares. I'll write that up there, difference of squares. So the way I recognize difference of squares is because there's 2 terms. Now check for a common factor first. 16 and 25 do not have a common factor. So let's see if difference of squares works. What can I square to get 16x squared? That would be 4x. Minus, what can I square to get 25? That would be 5. So this is my a and this is my b. That's what I'm going to plug in here and here and there and there. So this factor is to be 4x minus 5, 4x plus 5. Hey, just as a side note, it has to be a minus. Okay, it's got to have a minus in the middle. It doesn't work with a plus. Hey, make sure you're checking for a common factor. So you look at 18a squared minus 8. You can't square something to get 18 or 8, but there is a common factor. You can take a 2 out of both, right? So if I factor out a 2, 18 divided by 2 is 9, and 8 divided by 2 is 4. And now look at those 2 terms. You can write the first one as being 3a squared, and the 4 as being 2 squared. Okay, so now that's my a, that's my b. I go 3a minus 2, and 3a plus 2. And then don't forget the common factor we took out at the very beginning. Okay, so if it's got 2 terms, those are pretty easy to factor. We just have to recognize when that's the case. 3 terms are probably the most complicated. There's 2 different types of 3 terms. The first one is, if I have this, a squared plus 8a minus 20, this is the easier type. If there's nothing in front of the a squared, so if it looks like this, x squared plus bx plus c. So there's nothing in front of the x squared. It's pretty easy. All I do is my 2 sets of parentheses. These are the ones most of us are really good at. I just take a and a, right? What do I multiply together to get a squared? And then I have to multiply those to get negative 20. So I make my list off to the side. Be really careful with signs. To get a negative 20, it has to be a positive and a negative. So I could do negative 1 and 20, or negative 2 and 10, or negative 4 and 5. I need the one that adds up to be 8. So that one adds up to be 19. That one right there, negative 2 plus 10 adds up to be 8. So it's minus 2 plus 10. And I'm done. I factored it completely. So those are the easy ones. There's nothing in front of the x squared. One thing I want to point out is sometimes there'll be something in front of the x squared like this one. But if we check for a common factor, these 3 all have a common factor. So if I take out a 2, I end up with x squared plus 1x minus 2. Okay, now look at that inside part. That's still a quadratic trinomial, right? It's got 3 terms. Its highest power is a 2. But now there's nothing in front of the x squared again, so it becomes one of those easy problems. So 2 sets of parentheses, x and x. And what are the factors of negative 2 that add up to be 1? So you could do 1 and negative 2. That one adds up to be negative 1, so I just need to flip the signs, make it negative 1 and positive 2. So, negative 1, positive 2. Okay, and make sure you drop that common factor down. So sometimes even if there is a number in front, if you can take out a common factor, you can get rid of that. There are times, though, when there is not a common factor, and then we have to know how to do that. So I'm going to slide this down a little bit because we need a little bit of room to work on this one. 10x squared minus 11x minus 6. Okay, so what I see is I see that 10 out in front, and there's no common factor. That tells me this is going to be a harder one to factor. So if you do have a number out in front, our steps are this. You have to take the first times the last. So 10 times negative 6 is negative 60. And then you have to list your factors of that adds up to be negative 11. So let's list our factors. Negative 1 and 60, negative 2 and 30, negative 3 and 20, 4 and 15, negative 5 and 12. There's a lot of them. Negative 6 and 10, 7 doesn't, 8 doesn't, 9 doesn't. We're back to 10. So I want the ones that add up to be 11. We got a lot of choices. I think it's this one right here. Now that actually adds up to be a positive 11, negative 4 plus 15. So I'm just going to swap the signs. Now it'll add up to be negative 11. Okay, now we make this into a grouping problem. So the way we do that is I go 10x squared plus 4x minus 15x minus 6. So all I did is I replaced that minus 11x in the middle with those two numbers that I found. Make sure you include an x with them. So I replaced the minus 11x with 4x minus 15x. Okay, now do grouping. So I put the first two together, 10x squared plus 4x. Be careful, I've got a minus there, so you can put a minus there, but you've got to flip both these signs, so 15x plus 6. Make sure you change both those signs. Okay, take out your common factor. So out of this first one, you can take out a 2x. That would be a 5x plus 2. Out of this next one, you could take out a 3. That would leave me a 5x plus 2. What I'm hoping for this to work is those should come out to be the same. That's how you know you did it correctly. I've got a 5x plus 2 and a 5x plus 2. So take that out. 5x plus 2. Take that out of both of them. That leaves me with 2x minus 3. There's my factored form. So more work, right? If you've got that number out in front, that leading coefficient other than 1, excuse me, sorry. You've got to do a little more work. Times the first and the last. Find your list of factors. Add up to be the middle one. And then change it to a grouping problem. From there, you're grouping. Hey, one last problem I wanted to show you is sometimes you'll have a problem like this. It's 9x squared minus 30x plus 25 when it looks like a really hard problem. But there's a shortcut for this one. If you recognize that the 9x squared is a perfect square, and so is the 25, and then check the middle term. The way we check is we go 3x times 5 is 15x times 2 is 30x. It equals what's in the middle. What that means is instead of having to do that big, long way we just did it, it's actually going to be a perfect square. So 3x and 5, and then that sign right there just goes in the middle. So if I would have done that thing we did just barely on that last problem, I would have ended up with 3x minus 5 times 3x minus 5. But this is a lot faster, only when it's a perfect square though. And again, the way you check is 9x squared has to be a perfect square, so does 25. When I times those together and times by 2, it has to equal what's in the middle. So the 3 term has the most variations, makes it a little bit trickier. The only other one we had to do is 4 terms. We kind of already just reviewed that. It's just grouping, which we just did on that last problem. But let's go through one more. This one has a plus in the middle, so I can just group the first 2 together and the last 2 together. Take out your common factor out of this first one. Sometimes the common factor, there's not a number, like 8 and 5 don't have one, but they do both have n's. So take out an n squared. That leaves me with 8n minus 5. 56 and 35, I think your common factor is 7. So that would be 8x minus, or sorry, 8n, not x. 8n minus 5. Okay, now they both got a common factor of 8n and 8n minus 5 and 8n minus 5. Take that out. And that leaves you with n squared plus 7, and there's our factored form. So most of us, I think, are pretty good at grouping. The key thing is with grouping is that and that have to end up to be the same for it to work. If it isn't the same, you can try switching the 2 middle terms. Sometimes that will make a difference. But usually it's because either it doesn't factor or because you've made an error somewhere along the way. Okay, that should be all the factoring. So right, your test is going to include, you have to name a polynomial, you have to be able to add, subtract, multiply, and then all the factoring. And by factoring by far is the biggest part of it, the most complicated part of it. So hopefully that helps. Work on the review, make sure in the practice test, make sure you're ready for our test.